Doing good. And today we have taken one question from ray optics. Okay. Into this question, there is a glass plate in front of us. Okay. If this is the glass plate, then into the question, it has been asked that one face of a rectangular glass plate is silvered. Okay. Let us say this face is silvered. If this is the silvered face, right? If this is the silvered face, then it has been given that the one face of a rectangular glass plate 6 centimeter thick. If you are seeing it from side, then this glass plate is 6 centimeter thick. This thickness of the glass slab is given to you, and that is 6 centimeter. Right? Now, an object held 8 centimeter in front of the front face. So maybe some object is placed over here. Some object is placed over here. This is object. An object is placed over here at 8 centimeter in front of the front face. So this is the front face of the glass slab, and the object is kept at a distance of 8 centimeter from front face. So this distance is given to you into the question, right? Now, forms an image, this object forms an image at a distance of, forms an image 12 centimeter behind the silvered face. So behind the silvered face, 12 centimeter behind, this image is formed. This image is formed. I am writing this as image, right? This image is formed 12 centimeter behind the polished surface. So this distance behind the polished surface, this is the polished surface, and this image is formed 12 centimeter behind the polished surface. Find the refractive index of the glass. Then this glass is having certain mu. That refractive index need to be calculated, right? This mu need to be calculated. Now, my dear friends, when you look perpendicularly from here into the glass, you can see this polished surface will not be here. It will be at some apparent depth. So this polished surface may be looking like at some height, not at actual. So this depth of the polished surface will be basically resembling over here due to the apparent height concept, right? Apparent height, apparent depth, and this polished surface will appear here, right? Why? Due to the apparent depth. AP, A double P, apparent. So the polished surface, this is the actual one, this is the apparent one, right? And this is the actual ACTUL, actual polished surface, and this is the apparent one, right? Now, you can see, let us say this apparent depth from here is this distance is, let us assume it as x, right? If this is x, if this apparent depth is considered to be at x, so the apparent depth is equal to x, let it be, right? Then what will happen? Since the image is formed 12 centimeter behind it, and this is due to the reflection, the object here is the main object and here is the right. Since it will be acting like a plane mirror, this silvered surface apparently will be acting as a plane mirror. So the image distance in a plane mirror, what will happen? In a plane mirror, image distance is equal to object distance. Image distance is equal to object distance, right? So what is the object distance over here? If this will be the apparent depth which will be acting and which we are able to see, this will be the 8 plus x. This is the mirror. Let us see. This surface is acting as a mirror. Apparently, definitely, it's an apparent, right? Then what will happen? The object distance, which is 8 plus x, 8 plus x, right? What is the image distance? 12, this 12 plus, if the total width of the slab is 6, this one is how much? This one, the difference between the polished surface and the apparent polished surface. This will be 6 minus x. This 6 minus x. I am writing it over here. 6 minus x. So the image distance will be 12 plus 6 minus x, right? 12 plus this 6 minus x. Hope you got it. 12 plus 6 minus x. This one is this is the image distance, right? And this is equal to object distance 8 plus x, 8 in front of the slab, and x is the layer of the x inside the slab, which is the layer of the apparent polished surface. This one I am saying, this one. So when you solve it, it's a simple equation, linear equation. When you solve it, you will get 12 plus 6 minus x equal to 8 plus x. This will give you 12 plus 6, 18. 18 minus 8 is the value of x plus x. And this will give you 18 minus 8 is 10, and here x plus x will be 2x. So 10 by 2 is the value of x, which is coming as 5 centimeter. So the value of x is calculated as, this x is calculated as equal to 5 centimeter, right? This x is calculated as equal to 5 centimeter. Now, what is mu? This is the question to us. Mu, the refractive index of this glass plate, is equal to, you know the formula, real depth by apparent depth. This will be equal to real depth divided by apparent depth. What is the real depth? Real depth is nothing but this 6 centimeter. So just put a value of 6 over here in place of real, right? Real depth is 6 centimeter divided by the apparent depth. What is apparent depth? We have calculated, my dear friend, x equal to 5. So just put it over here. 5 centimeter. Centimeter will be cancelled, and 6 by 5 will give you a value of 1.2. So 1.2 is the refractive index of this glass slab, my dear friend. This one, this glass slab is having a mu, and that mu is calculated as equal to 1.2. No unit will be there, and here cm will be cancelled out, right? Mu, the refractive index of glass slab. Is mu equal to 1.2, and in this way we have solved this question, my dear friends, right? Let me read out the question once again. One face of a rectangular glass plate 6 centimeter thick, this is given to you. This face is silvered. An object held 8 centimeter in front of the front face forms an image of at a distance of 12 centimeter from it, right? Find the refractive index of this glass slab. What we did, we just, we know the concept of apparent depth, because this glass is having certain refractive index which is that of air, because here it's air, here it's air, right? And here we have glass. So definitely this will be denser medium. Due to the denser medium concept, the glass slab, which is having a polished surface over here, will not be here actually. It appears to be here. That's why I have written it actual. So the polished surface is here, okay? But since it's a denser medium and made up of glass, and here it's an air, when we see from this side, this layered or polished surface appears to be here. So that's the apparent depth. At a depth of x, this polished surface will appear over here, right? And the concept of apparent depth, we know that real depth by apparent depth is the value of your refractive index, mu, right? So mu is real depth by apparent depth, right? And what is the value of real depth? My God, real depth is definitely, you can see this is 6 centimeter, because from here the width of the glass slab is nothing but 6, right? So this polished surface is at a depth of 6 centimeter from the point of observation, if this is the point of observation, right? So 6 centimeter is the real depth, and the apparent depth is calculated that as x equal to 5 by the simple calculation, because it will be acting as a plane mirror, and for a plane mirror, image distance equal to object distance, and image distance is nothing but 12 plus 6 minus x, which we kept over here into the LHS. And the object distance, if this is considered as a reflecting surface, if this is considered as a reflecting surface, from here we have object, right? And from this reflecting surface, this side we have image, right? So from here, if you see, x plus 8, x plus 8 is the object distance, right? And from here, the image distance is 12 plus 6 minus x. 6 is the glass width, x is the apparent depth, so 6 minus x plus 12. This will give you, this will be the image distance, which should be equal to the object distance of 8 plus x. When you solve it, you get the value of x as 5 centimeter, which is nothing but x equal to, x is your what? Apparent depth x. So apparent depth is calculated over here as equal to 5 centimeter, right? So we know the real depth by apparent depth is gives you the value of mu, the refractive index of the glass slab, right? And refractive index of the glass slab is real depth by apparent depth, and real depth is 6, apparent depth is 5, which we calculated. Put it over here and get 1.2 as the value of the refractive index, right? So in this way we have solved this question, my dear friends. Just be connected. See you. Be learning. Be bye. Bye bye.